Good morning, dear students. I hope that you all are doing well. Let's continue with lesson 2, acids, bases and salts. In previous classes, we have discussed the various particular salts. We have discussed the properties, preparation and uses of some salts which are of sodium and calcium. In chemistry, salts are ionic compounds that result from neutralization reaction of an acid and a base. They are composed of related number of cations, positively charged ions, and anions, negatively charged ions, so that the product is electrically neutral. There are specific properties of these salts. That means these properties are special properties such as crystalline solid, hard brittle solid due to strong ionic bonding throughout the crystals, high melting and boiling points. The salts dissolve in water into free moving ions and able to conduct electricity. Something that conducts electricity in solution is called an electrolyte. Molten salts also conduct electricity, but solid salts do not. Ions must be free to conduct electricity, and in solid state, these salts do not have free ions. Apart from this, the salts also possess one more feature, that some of the salts contain a few water molecules as an essential part of their crystalline structure. So today we will discuss about these water molecules as water of crystallization. Water of crystallization refers to the water molecules that form an essential part of crystalline structure. The water molecules which form part of the structure of a crystal of a salt are called water of crystallization. If we consider the example, a few examples are here, such as copper sulphate pentahydrate, cobalt chloride hexahydrate, sodium sulphate decahydrate. The empirical formula for water of crystallization has a unique presentation. It has a dot in between the compound and water component of the crystal. So the naming of the salts also do include the two parts, the name of the salt and number of water molecules present to it. First part, if we'll consider of example 1, then it is copper sulphate. 5 molecules of water present, therefore pentahydrate. It can be also said as hydrated copper sulphate. Hydrated salt. Salt that contains water of crystallization is called hydrated salt. Like for example, copper sulphate pentahydrate, sodium carbonate decahydrate. Opposite to it, anhydrous salt. Salt without water of crystallization is called anhydrous salt. Like for example, copper sulphate and sodium carbonate. A few examples of crystal hydrates or hydrated salts are given in this table 7.6. Cobalt 2 chloride hexahydrate, copper 2 sulphate pentahydrate, iron 2 sulphate heptahydrate, magnesium sulphate heptahydrate, sodium carbonate decahydrate, sodium hydrogen sulphate monohydrate, sodium sulphate decahydrate. Salts that contain water of crystallization to have specific chemical formula attached to this specific number of water molecules. Crystalline solid held together by water molecules to form crystals. The water of crystallization gives the crystals of the salt their shape, and in some cases impart them color. Salt without water of crystallization are anhydrous salt, as no water of crystallization is present to such salts. Therefore, these do not have crystalline shape and are colorless. Water of crystallization can be removed by heating. Water is driven off. The picture we get here when we think of copper sulfate is royal blue crystals. In fact, this is just one form. This is the hydrated form, which contains water, water of crystallization. The anhydrous form with no water is just a white powder. This is the reason such salts do have their common names as per the color these impart in hydrated form. Blue color imparted by copper sulfate pentahydrate is also known as blue vitriol. Hydrated and anhydrous copper sulfate undergo changes. This hydrated copper sulfate, blue in color, on heating turns anhydrous copper sulfate white in color, along with 5 molecules of water which evaporates or goes away. Due to the loss of water of crystallization or the dehydration of copper sulfate crystals, there is color change from blue to white. This dehydration of copper sulfate crystals is reversible process. So when anhydrous copper sulfate is present with specific molecule of water, or when water is added to it, it turns hydrated copper sulfate with only taking 5 water molecules of water from the surrounding by adding water. Differences between hydrated and anhydrous salts. As definition says, hydrated salts are salt compounds having water molecules attached to the salt molecules, contain water of crystallization. When hydrated salts are heated, water molecules evaporate. Anhydrous salt, on the other hand, are compounds or salts having no water molecules attached to the salt molecules, have no water in the salt crystals. There is no water evaporation from anhydrous salt. So with this, we are completing the study of salts altogether with all its properties. Now let us see the summary of the lesson. In this lesson, we have studied about acids, which is a class of compound whose water solution tastes sour, turn blue litmus to red, and react with bases to form salts. We have discussed about bases, a class of compounds that taste bitter, feel slippery in water solution, turn red litmus to blue, and react with acids to form salts. We have discussed about salts. These are items that are neither acids nor bases, but are neutral mostly. Some of the acids are in nature are organic acids. Similarly, some of the bases are in use in our daily life. This shows a list of acids and its natural sources. Like for example, lactic acid is in curd, oxalic acid is in spinach, ascorbic acid is in amla, citrus fruit, tartaric acid is in tamarind, etc. The bases which are in use: calcium hydroxide as in lime water, sodium hydroxide as in soaps, magnesium hydroxide in milk of magnesia. Properties of acids. Taste sour. The word acid itself comes from a Latin word acidus, which means sour. Acids change litmus from blue to red. Their aqueous solution conduct electric current are electrolyte. These acids are ionic compounds. Acids react with bases to form salts and water, evolve hydrogen gas upon reaction with an active metal, and so on. Uses of acids are numerous, some of which include in stomach for digestion, in car batteries, in manufacturing of fertilizers, in food industry, in soap making, and in medicine preparation. Properties of bases. Bases taste bitter, feel slippery or soapy. Bases do not change the color of litmus paper when it is not strong. They can turn red litmus back to blue. There is no change in blue litmus paper. Their aqueous solutions conduct electricity and are electrolyte. This also proves that bases are ionic compounds, react with acids to form salts and water. Some of the bases are in use, like for example, sodium hydroxide is used in the manufacturing of soap, as in petroleum refining, in making medicine, paper, pulp, etc. Also in making rayon. Calcium hydroxide is also known as cleoctaline, is used to neutralize acid in water supplies, to manufacture bleaching powder, as a dressing material for acid burns, as an antidote for food poisoning, in the preparation of fungicides, in a mixture of whitewash. It is mixed with sand and water to make mortar, which is used in the construction of buildings. It is also used by farmers on the field to neutralize the harmful effects of acid rain. Ammonium hydroxide is used to remove ink spots from clothes and to remove grease from window panes. It is used in cosmetic industry. Alkalis such as potassium hydroxide is used in batteries. The Arrhenius concept is based on the type of ions produced in aqueous solution by acids and bases, and the definition then is as acid is a substance which yields hydrogen ions or hydronium ions in aqueous solution. Examples: hydrogen chloride in the solution as hydrochloric acid, sulfuric acid. A base is a substance which yields hydroxide ions in aqueous solution. Examples are potassium hydroxide, sodium hydroxide, magnesium hydroxide, etc. Chemical properties of acids and bases include: acids react with bases to give salt and water. Acids react with active metal to liberate hydrogen gas. Acids react with carbonates, bicarbonates to liberate carbon dioxide gas, along with the formation of salt and water. Reaction of bases. Bases react with acid to give salt and water. Bases react with ammonia to give ammonium gas. Ammonium chloride is the salt here, which reacts with sodium hydroxide to release ammonia gas. Bases react with soluble metallic salts, giving metallic hydroxide precipitate. Like for example, sodium hydroxide reacts with copper sulfate solution to give precipitate of blue color of copper hydroxide along with sodium sulfate. pH scale is the measure of acidity or basicity of a solution. The scale ranges from 1 to 14, 1 to 6 for being acidic substances, 7 is considered neutral, 8 through 14 being basic. It is defined as negative logarithm of hydronium ion concentration of an aqueous solution used to express acidity. We also discussed about the salts, the last topic of the lesson, which is the substance chemical compounds, ionic compounds formed as when hydrogen ion of an acid is replaced by metal ions of bases mostly. Like for example, sulfuric acid when reacts with sodium hydroxide, the H plus ions of the acid is replaced by the sodium ion forming salt sodium sulphate along with water molecules. The preparation of salts as a result of neutralization reaction releases heat, also is the example of exothermic reactions. Another very common salt is the table salt. Chemical formula is NaCl. Properties of salts include these are crystalline solids, may be transparent or opaque. Most of the salts are soluble in water. Solutions of salts conduct electricity. Salts may be salty, sour, sweet, bitter, umami, that is savory, tangy, etc. Neutral salts are odorless, and salts can be colorless as well as colored. Lastly, we have discussed about water of crystallization, which is the fixed number of water molecules present in one formula unit of a salt. These water of crystallization water molecules evaporate or just remove when we heat the salt. On strong heating, the loss of water of crystallization can change the crystalline shape of salt as well as the color the salt imparts. With this, we are completing the lesson. In our next class, we will start with the new lesson. Thank you.